Welcome back to this next video. And in this video, what we're going to talk about is data structures. And data structures actually break down into several different things: lists, tuples, arrays, sets, dictionaries, and lists. So what we're going to do, we're going to spend about an hour in this video, and we're going to talk through each and every one of these, as well as how to go about using them the way we want to in Python. Now, you may already be familiar with different programming languages already, but for Python, it's going to be a little bit different. And just so you know, we're not as heavily dependent on arrays as we are maybe some other programming languages like C++ or Java. The first data structure we want to look at is lists. So let's go over to Visual Studio and have a look at that. We've seen already in the past something that looked like this list that we want to do. And it started with square brackets. And what we can do in here is we can have, let's say, a list of letters. So if we do A and then we move to the side, we do another letter and we're going to say B. And let's say we want to add C to this as well. We can do that. And what we can do once we create our actual list is we can now assign it to a variable. Okay, so this variable is actually is now just a list of things that we want to save. Now, the really interesting thing is we can also have numbers. So if I want to say numbers, okay, I can do the same thing, and I can do 1, 2, 3. This is my list of numbers. But the other thing we can actually have is something really important, and you might want to hold on to this inside your internal memory bank. And we're going to say a list of lists. Okay, and the list of lists is going to look like this. So let's say I do a set of square brackets, and inside my square brackets, I do another list. And inside that list, it's going to look like this: 0, 1. Okay, and then I'm going to go and I'm going to make another list inside my lists, and I'll do square brackets again, and I'm going to say 2, 3. Okay, but what this starts to create is something called a matrix. And that's what that is creating. A matrix is a list of lists. Okay, and we're going to be using matrices very soon in the near future. So make sure that of all the types of lists, you get a little bit comfortable with this particular one. So let's say I wanted to have for some reason, a list of zeros, and I wanted 100 of them. I wouldn't want to do something like this. I wouldn't want to say 0, 0 like 100 times. That would be really inefficient and somewhat ugly to try to read. But what you could do is you could do something like this. You could say 0, and then I could multiply that by 100. And what I'll call this is zeros. Okay. And now if I want to print out the effect of that, what I can do is call my print function, and inside my print function, I can type zeros. Okay, and now I'm going to save that, and let's go ahead and see how that looks. Okay, now look at that output. Clearly, it would be just horrendous of me to try to do this manually. That's why we're using lists and the print function to do something so utterly bizarre. But understanding how this works is going to come in handy in the near future. Now, suppose I wanted to go ahead and combine some of my lists together to have one output. And I'm going to change this to, let's say, 5. Okay, and I'll go down to the next line, and I'm going to create this variable called combine. Actually, combined. And I'm going to do zeros. Okay, that's there in my option list. And How about letters? Okay, and now instead of printing out zeros, I'm going to print out combined. Let's go ahead and run that and see how this actually looks. And there you have it. I'm printing out a combination. In a sense, I'm concatenating the two lists into one. And you can see I have 5 zeros here, and then I've output my 3 letters. And what's really, really interesting about doing this is that you'll notice that letters, this is a list, okay? And the data type for this is a list. Numbers, my data type is also a list. Even though inside my list, it is a list of strings, okay? This is also a list of integers. But when I assign them to an actual variable, what this means is I've now assigned those list of integers into the type of list. And so that is why I'm able to go ahead and combine the two into an actual list. So if we look at this combined, what combined becomes is also a list. Okay, so the data type of combined is not an integer, it's not a string. The data type is actually a list. Let's try something else. Suppose with after combined, let's say I just want to print out an entire list. Okay, and in my list, I don't want to do it like this. I don't want to do 1, 2, 3, 4, all the way up to 20. I don't want to do that. Okay, it's very inefficient. Now, the good thing is we've already covered what functions are. I can call the library function list. And inside my list is actually, what you can see here is iterable. And we talked about iterations in previous videos. So what I can do now is, instead of this 0, I can actually go ahead and type in range. And in my range, I can define how far I want it to go. So let's say I want it to go to 20. Now, that's going to perform that entire operation, but let's change it to a variable. And I know up above, I've already got the numbers up here, but let's go to here and change that. So I've got this number here, and I want to print this out to my screen. So let's save that and run it. And you can see what's happening right here. Okay, it is actually 20 elements long, but it is starting at 0. Okay, it's going from 0 to 19. So technically, that is printing out 20 different integers, but its starting value is going to be 0. Now, remember, it didn't get confused between this list of numbers or this list of numbers. And that's because the compiler has gone from the top down to the bottom. And it's actually taken the latest or the most recent as it came towards the bottom. It grabbed the appropriate variable numbers. Okay. Let's try doing something similar with strings. So let's say I do list, and inside here, I'm going to say, my name is Tom. Okay, and I'm going to put this in here. And these strings are just a list of characters. And in other types of data or programming languages, we have this thing called a char or character. And I'm going to put this in here, and let's print that out and see what the result is going to be. So save it, and let me clean that up. And let's output this to the thing. And you can see here that it is dividing up that entire string, including the spaces in between words here and here and here, as well as separating out each of the characters in the sentence. Okay. Let's try to get the length of those char characters. And to do that, no surprise, it's the same as before. What we can do is our len function that we can call and just close off the appropriate number of brackets. So I'll save that and then run it. And you can see that it gives me 14 characters. One thing that I want to do before I go any further is sort of change the way I'm running this program. You can see that I've been running it the whole time in the terminal. I actually want it to start showing up in my output. And so I got to do a little bit of reconfiguration to the IDE. And I probably should have done this right from the beginning, but I saved it to now. And because we're going to be running this a lot, I need to make this change now, I think. So let's go to the extensions panel, and I want to look for in here code runner, and you can see it's the very first one that pops up. So I'm going to go ahead and install it, and you can see right here at the top it's got 6 million different installs. So I'm going to run that. That's uninstall. I want to install, and it's now installed on my machine. I'm going to close down this extension window. And I'm going to close this as well. And you can learn some more things about it if you really, really want to. But you can see, that is inside this window, and it's giving me more information if I want it. So I'm going to close that. So really, the best way of doing this is actually Control-Alt-N. And I'll go and do that right now. Control-Alt-N. And you can see what's happening here is that it's showing that my code is now the default setting down here, and it's showing what my output is. And just so you notice with this particular output, it's just a little bit cleaner. That's all it is. It's a difference between running it in the terminal where it was very messy. This is now just outputting in a different way. I think this is just slightly cleaner for us. Let's continue with what we were doing. Now that we're done the changes to the IDE, let's go back to lists, and I want to talk about some theoretical concepts which are relatively common to all of our different data structures. And it's this idea that lists actually reside inside a memory model that looks something like this. So picture this in your mind. What we have is these little elements, and these elements are addressed by 0. They start with 0 and they go for as long as we need them to go. So in this case, they go to a maximum of 10. And what happens is we can actually add things inside each and every one of those elements. So if we want to refer to these elements, we just basically have to do it by their element number. So A has an element number of 0. C has an element number of 2. Okay. And if it's the same thing if we have different things inside of our list. So for example, if we don't want it to be strings inside our list, it can be integers inside of our list. But ultimately, they will reside in the same element address. Okay, so I wanted to get that out of the way because I want to go back over to Visual Studio Code and look at how programmatically we can access each and every one of those elements to get back the value that we want. Now, if you're actually still a little bit unsure about how this works, think of a townhouse or a row house. The only difference being is that nobody's row house actually starts with 0. Nobody lives at an address 0. Okay, so think about that. Think of these being row houses, and each one of these little units has an address of its own. Okay, so the first address on this little row house would be 0. Okay, clearly nobody lives at 0, but you understand the analogy that I'm trying to get at. So if I have this list called letters, and I want to access or print out just one of the individual ones that I want, I can do print. And the way I'm going to reference this is through its actual memory, or I shouldn't say memory address, but its element address. So let's say letters, and I want to access the very first one, and I'm going to call 0. Okay, so I'll save that, and let's run that and see what it looks like. And you can see that I'm getting A. And if I change this up and I want, let's say 2, okay, save it, and my expectation is now it's actually printing out C. Okay, and I'm gonna click this little icon here to get it to auto scroll from now on. Okay, so what happens if I do this and I say 3? I want it to go to address number 3. Now I want you to think about this if you're not fully comfortable with it. What am I gonna get? What am I going to get here? Okay, and look down and you can see there's a problem here. And it is this line right here. List index out of range. Because if we think about the way the elements are labeled, we actually start at 0, 1, 2. And if we tried to identify 3, we'd actually be wrong. We would actually, to make this correct, to solve this, we would have to have D. Okay, and if I save that and then I run it again, now I'm getting D and there's no error. Suppose now I want to put in a negative number. If I type in -1, what do you suppose the output is going to be? Well, let's run it. And you can see that our output is the same as if though I was calling 3. It goes through memory to the very end of our sort of memory model that we looked at earlier, and it gets the last one. It gets the last element. It goes to the end. Now remember what I said before, the compiler goes from top down and it bounces around kind of. So when I say that it goes top down, yes, that is in fact true, but sometimes it takes a couple of detours. So now let's say this. Let's say I want to update my letters and I want to change element 0 to actually become a capital A. All right. And let me just print off what my letter list is going to be. So I'll save that and I'm going to rerun that. And you can see now within my list, I was able to specify within the entire list which one I wanted to do just by calling element 0. I want to go over something that we looked at quite a while ago. And I can make these little updates. So let's say I want to have, I want to do some accessing here, but I want to go this way. This is how I want to do it. So let's look at the output here. And you can see the output here is identical. It doesn't really change anything. Actually, it did change something, but guess what happened? I forgot to save it. So where we saw this 4, the expectation now is that I've updated and saved it. Now I'm going to run it and see here, I only get the first 3. And that's because what I'm saying is go to a maximum of 3 and back up 1 element space. Okay, so let's say if I take this line of code again, I copy and I'll paste it down below, just like before. I don't need to put this first 0 here to make it have an output of the same thing. So there it is again. Okay, so this is something that we've seen in the past as well. And then, I could do this again and I can change the way I've done that. And I can get rid of the 3 and not give it a default and just say start at my 0. And then I save that. I'm going to run it. And you can see now that all 3 of them are printing, but this one here doesn't specify an ending other than the ending of the entire list. And finally, in this part, what I can do is take this out and save that, and let's run that and see what we get here. Same thing exactly. Okay. Now here's one other sort of playful thing you can do with this. What happens if I put 2 colons in there and then I put in a number? What I'm going to say with this is go ahead and print out every second value inside my elements or inside my list. So when I run this, you can see down the bottom, it says, go get me A and go get me C and return those to my console. Okay. Let's just take a minute and let's look at this all again. So we'll change out this one. In fact, let's just get rid of everything and start over. So we want a list, and we're going to do this list in a range, and that range is going to have a list of 20 numbers. And let's go over here and put this into numbers. Okay. And now that we have that, let's print that out. And what I want to do is just print every second number. And so what I'll do is I'm going to wrap this numbers in the print function. And just like this, I'm going to say print out every second one. And it's not period, sorry. It's actually colon. All right, let's save that and let's clear this off and then run it. And you can see right here, it's 0, 2, 4, 6, all the way up to 18, and it doesn't go to 20. Okay. Now, had I actually changed this to 21, it would have included up to 20. And there you can see it right here. Okay. So that's one way that you can get access to those without actually having to explicitly type out all the numbers inside of your code. So what if I want to actually return the items in the reverse order? I can put a negative here, save that, and let's run that and see what's happening. Now I've got the numbers in the reverse order, 20, 18, 16, all the way down to 0. What I'm going to do is just clean this up, and we're going to talk about something. We're going to do unpacking of a list. Okay, so in this list, we have typical 1, 2, 3. That's our list. And we're going to want to unpack that. And what does that really mean? So let's try this. Let's say first, and we're going to set that to number is going to be, we're going to go and get the first one. Okay, and then it's going to be second. And this will be numbers. And get the second number, and then third. There. Now, if you found that that was really painful to watch me try to type all that into my code, well, then you would have also been in agreement with me. I found it really painful to try to type up those lines 2, 3, and 4. I found it cumbersome and a little bit annoying, if I'm being honest. There's a better way of doing this. So let's create some space and go and do that now. So I can do it like this. I can say first, second, third, and I can set those to numbers. It is absolutely identical to what we have right here. Okay. And this is really what is referred to as list unpacking. So in order to make this work, the left-hand side variables must equal the same number of elements in our list. If you don't have it equal, it's not actually going to work. You're going to get an error. So suppose in our our list, we have a bunch of additional numbers. Okay, so 4, 5, 6, 7. Okay, we don't want to type out 4, 5, 6, 7. That becomes a little bit cumbersome itself. So we could do something like this. We could do an asterisk and type out other. Okay, with this syntax, we can actually go ahead and grab all of that stuff. So if you want to know how I'm going to print all this stuff, so let's say I want to do a print and I want to look at, let's say, third. I can do this, but now I want to print out the rest of it, print, and I can now just go to other. Okay, and let's save this and run it. And let's see what's happening. So you can see here, I'm getting the third one, which was 3. And the rest of it I'm getting as other is 4, 5, 6, 7. So that's how that works. That's a really useful tool for doing unpacking. So I can do some really interesting things with this too. I can move this stuff around and let's say change this to last. Okay. I can do that. And then let's say I want to print this all off. Now I'm going to go and change this to first and last. And I still have other over here. Okay, so let me go ahead and save that and print that off. And you can see what's happening. I'm printing the first, the last, and then everything in between the first and the last is now being output to my screen. Next, I want to show you something really interesting. And if you're, again, an experienced programmer or you've been in a different language before, you would have known that anything that resembles an array or a list or anything like that is typically going to be used in conjunction with a for loop. And the way we could do that here with this is we could say for number in numbers. Okay, and don't forget your colon at the end. What I want to do is print now letter. Or sorry, not letter, sorry, number. And of course, up here, I spelt that wrong. Okay, so this is how I would do this. This is very, very similar in effect, the way we would use a for loop in, say, a programming language like C, C++, Java, JavaScript. We'd use a for loop. But the way we're doing it here, it's a little bit different. Now, if you're still, again, questioning, like, how do I know if this one's number? How do I know this one is numbers pluralized? Understand the difference between the two, right? This one is a singular noun, and this one here with the S is actually the list itself. So if I highlight over top, just know that the second thing here is the actual list. This is just a variable, okay? And it is predefined the actual data type. It is defaulted that data type because these here are all integers. Okay, so that's an important thing to understand here. So if I save this and I go ahead and I run it, and you can see that it outputs everything here, 1 all the way to 7. Okay, so that's what's happening there. Now I've introduced the idea of a tuple already before, but I want to show you a method where not only do I get to output the number itself, but I also get to output which element it belongs to. And just for clarity, because I don't want it to be too confusing, I'm going to change this to 2, 4, 4, and let's see, 6 and 8. I'm going to change that. And the reason is, which will become very clear in a second. Now, what I can do is if I put numbers in brackets, it's because I want to call this function called enumerate, sorry. So what that's going to do is not only is it going to print out my numbers, but it's also going to tell me which element that they belong to. So I'm going to save that and I'm going to run that. So you can see down here that our number 2 is in position or in element 0. And number 4 is in element 1, 2, and 3. Okay, so you get the idea. This is telling me which element they belong to. Really important if you ever need to know exactly which one. And maybe because you're doing some debugging, you're going to have to figure that out. And I want to take this opportunity to remind you that within a tuple, it is read-only. Okay, I can't make any changes to that. It is read-only for a tuple. Okay? So how do we go about once we know that we have this list, how do we go about adding and removing items from the actual list? And one of the things we can do is do these method calls. And I can call the append method and add 25 to the end of my actual list. And likewise, if I want to add something to the beginning or to the end, the middle, sorry, I can call my insert method. Now, if I want to remove something, then I can call my pop method and it'll pop it off of the end. Okay, so these keywords or methods that you hear are pretty common across multiple different software languages. I know for sure that you would have these inside of C++, and if you were doing anything with, let's say, iOS or Android development, you would have these built-in functions as well. And where you might want to use those is to say you have a contact list in your smartphone. That's one example. So let's go over to Visual Studio and see how this works. So suppose I have this particular example here. I've got numbers 5, 10, 15, 20. And let's say I want to add a number to the end of this list. So I could say numbers and call the append function. And you can see when I hit this dot, all of these different method calls actually show up. Okay, and remember what we said earlier about the difference between a function and a method. Okay, we are calling these library methods on the variables that we've created here with our list. Okay, so I'm going to call the append method, and what I'll do is at the end, I'm going to say 25. Okay, so let's save that and then test it out. And you can see here now that I've got 25 added to the end of this. So let's try it one more time, and we're going to say numbers, and we're going to call the, what do you think? What did I say before? Insert. So we're going to go to insert. But with insert, I have to specify, I have to explicitly tell it which element that I want it to go. And by the way, you can also refer to these positions not just as elements, you can also say that they're indexes. I think the term is relatively interchangeable, and that's debatable. But you know, that's okay. So let's add this to the very first one, and I'm gonna put in a comma, and I'm gonna say what I want to do is add this string value of a hyphen or a dash, let's say. Okay, so I'll save that, and then let's see what happens. Okay, run that, and you can see now that I'm getting this dash at the very beginning of my list. So if I want to remove at the very back end of the list, what I'm going to do is I'm going to move this down. Okay, and right here, I'm going to say numbers, and let's say right here, pop. I want to pop off the last number in the list. Okay, and so I should be removing now this 25. So I'll save that and let's run it. And you can see that the list has been updated and 25 is no longer there. But I can use pop to specify where I want it to disappear. So in this case, I'm going to say I want at position 3 for this to disappear. So let's go ahead and save that and then run it. And you can see here that 15 disappeared. Okay, so it went from 510 to 20, and that worked out perfectly. Okay, so what happens if, for example, for some reason, I just don't know what the actual index or element number is, and I want to remove something very specific within my list? What I can do is just type in numbers dot, and it's right there, remove. Okay, I can go to remove, and I can specify exactly what I want removed. And in this case, I want to remove the very first instance inside our list of the number 10. So I'll save this and let's run that. And you can see here that 10 has been removed from that position. So just to be clear, when you use remove, it will only go to the very first and only instance of the 10, for example, here. If there's a 10 in this list further down in the list, it's not going to remove that one. It's only going to remove the very first time it sees the number 10. Okay, and if you want to remove each and every one of them that is 10, if there was multiple 10s in this list, you'd end up actually having to iterate through this with a for loop. Okay, but in this case, if you want to remove just the 110, you can do it really easy with the remove method. So there's another thing that we could possibly do if we wanted to remove more than just say one at a time. What we can do is sort of specify a range. And the way we do that is we use something called the del, and that's actually short for delete. Okay, so we're going to say delete numbers, and we're going to specify what the range is that we want deleted. So in this case, I'm going to say delete 1 to, I don't know, let's say 3. Let's see what happens here when we do this. Okay, now there's one other thing that we can do if I just want to clear out everything. I just want to delete the entire list. I can just do numbers here and call the clear. And it's not calling it up. Anyway, clear is one that I can do. I can just call up the entire list and get rid of it. So let's just see what happens really quick if we comment this out, and I want to show this delete. Okay, in fact, what I'm going to do is I'll go from 0 to 2. Okay, and I'll save that and let's run that code. And you can see that in fact did get rid of 0 and 2, or whatever was remainder of that. Now the last thing I'm going to do actually is uncomment this out and run that, and you can see that I didn't save it, and I need to save it before I run this. And let's run it again, and you can see there's nothing left. I've cleared out the entire list. Let's clean this up, because what I want to show next is actually how to actually find an item inside of your list. Okay, and remember what I said before, it's kind of an interchangeable, depends on who you talk to. I prefer the title of element. Some people prefer index, but I suppose I should give up to the fact that there's a function called an index, which is meant to help you find exactly which index or element that you're actually in. And so let's say I have this number list again. And what I can do if I want to print it out and I want to know exactly which element is the number 10, one of the things I can do is I can call my index method. And there it is. I can call the index method and I can add in here and say, okay, which one is at number 10? Okay, so I'm going to save that and I'm going to run that. And you can see down here that, as expected, number 10 is at the index or the element 1. Suppose we have this list of numbers and they're not sorted. They're not in any sort of ascending or descending order. One of the things we can actually do now is we can call numbers, and obviously I believe you're probably going to guess this by now, is I can actually just call my sort method, and then I can run that just like this, just as is. So let's go ahead and run that. And you can see now that it's actually sorted in ascending order. So 1, 6, 28, 75. Okay, so that's really good that we can do that. So what happens though now if we want to go in the opposite order? Okay, this is ascending order. We want it to be descending order. Okay, and the great thing is that this method here actually has some really good information in here in the library, but for some reason it doesn't want to pop up on my screen right now. But what I can do is actually send this almost like a parameter. and we can call it reverse. And you can see that it does actually pop up, and I can set this to true. And if I set my reverse to true and then I save it and then I go ahead and I run it, you can see that it is now sending it or displaying it in my output in the descending order. Okay. I think as far as lists go, that's really as far as I want to take this. We actually covered quite a lot just in the list section itself, and we've got quite a bit to go. And everything that we've done is we're gonna build on it with the other data structures anyway. But anyway, I'd like to end off with list, and let's move on from the lists. What I'd really like to start talking about now is tuples. I want you to think of a tuple like a list, but like I've said before, it is read only. In no way can you actually do any modifications to a tuple. So that is one of the downsides, but that's okay. We can work with tuples, and there's reasons that we actually do use them in Python anyway. So I want to start off and say coord. Okay, and I don't want it to be chord. Let's do this, coordinates. Okay, and what I want to do is say in my brackets here, I want to say 1 and 2 as an example. Okay, and so when I save this, you can see that Pep8 will space everything else in nice and neat. But just so you know, for a tuple, I don't have to have the brackets. Okay, I can actually take those out. So there, no problem there. So Python does see this as a tuple because of the way that's configured. But what I want to do is just for my own sort of visual clarity and immediately know what I'm looking at, I'm going to keep the brackets in there. And I know that the equal sign is in there, so that doesn't tell me that it's a function with 2 parameters in it. Okay, so just to figure out what the type is, what I want to do is, let's say a type. I'm going to call my type function again, and I'm going to call it on chords. And really that's not chords, it's coordinates. So I'm just short forming chords. Okay, and then I'm going to wrap this actually in a print function as well. Okay, and let's have a look at this. Okay, and this is something that we're going to come to in a future video. We're going to talk about classes. And actually in the next video, we're going to get into defining classes and creating objects. Okay, so for now, let's just have a look at this. And you can see that it views it as a tuple. Okay, so let's suppose there is only one item in there. Okay, it's going to think that it's just an integer being assigned to coordinates here. Okay, and that would be a mistake. So what we want to do is make sure so that the Python still knows that it's a tuple, is we want to put that comma in there. Okay, and then let's run that again. And you can see it still believes that it's a tuple. And if I take it out and then I try to run that, you can see, well, I didn't save it, but you can see that when I run this again, it believes that it's an integer. Okay, so we want to make sure that if there's only one in our tuple, we're going to have the comma there just to make sure Python understands. Now, if you have an empty tuple, okay, make sure that you keep the parenthesis there. Okay, keep that there. It's the only way that it's going to know it's a tuple. And what I'll do is I will save this and then I'll run it. And if you can look down here, you see that it's a tuple. Now, another thing that we can do is we can concatenate our tuples. So if I say 1 and then 2, and then I actually add another tuple here, and I say 3, 4, and then I decide that I want to print this out and have a look at the result. I can do this, and now I'm actually concatenating my two tuples. Okay, I'm not manipulating what's inside the tuples. I'm just concatenating them into one bracketed form of the tuple. And here's another really fun thing that we can do. I can say multiply this by 5. Okay, and I'll save that, and let's run that and see what happens. And what it's done is it's gone 1 2 1 2 1 2 1 2 5 times. Okay, so that's another interesting thing we can do with a tuple. Now let me clean this up a little bit because I want to show you where we talk about these being immutable, and meaning that we cannot make any changes to these things. Okay, so let's say if you remember with our list, we were adding to the list, or we were modifying the list based on the index. Okay, so if I were to try and say coords and identify it by its actual element, which would be, let's say 1, I'm going to try and change that 2. And I want to reassign the 2 on line 2, or line 1. On line 1, I want to change the value of 2 inside my tuple to, let's say, 5. So what I'm doing is I'm actually trying, and this should be actually a 1. So what I'm saying is I want to change this value to a 5. And you remember this is 0, 1, and 2. So if I try to make that assignment to a 5 and then print it off, I'm going to save that here and then run. I wanted to attempt to run it, but look at what happens right away. Right down the bottom, I've got a problem. And down here, you can see I've got an error and I've got all this red mess over on the side. And now I'm getting this squiggly line underneath coords. It says right here that does not support item assignment. Okay, so it's unsupported assignment operation because it's a tuple, and tuples cannot be reassigned. They cannot be changed. They are read only. Okay, so that's really important to understand. Now, had this maybe been a list, okay, if we'd have done this, this probably would be legal, right? So let me save that. And now I could have gone and actually changed that. So if I print this, you can see now I was able to do that with a list, but with a tuple, I cannot perform that operation. So this begs the question, where in the world would I use a tuple? Okay, and it's when let's say the list of things that you want to store, you absolutely for no reason want to change those. And one example off the top of my head I can think of is the days of the week. Monday all the way, 7 days later to Sunday. You don't want to make any changes to that at all. So maybe that's an appropriate place to use a tuple. Okay, so that's one really good example. The next thing that we need to actually talk about now is arrays. And most programmers that have started out in different languages are very familiar with arrays. So if you haven't, that's okay. We're going to cover it. And for the most part, if you are doing everything that you need to do with a list, that's perfectly fine. That's great. But it's when you start to get a huge list and you're getting performance issues that you may want to consider switching everything over to an array. Okay, but lists are still good. Arrays are better in terms of overall performance. Now, in order to use an array, the one thing that we actually have to do is go to get this from the library. And we have to say from array import array. Otherwise, we can't perform array operations. So we need this in here. And this first array here is actually a module. And we are going to talk about modules in a future video right after classes. But just so you're aware, we have to get the array module and we're importing from the array class. Okay, and if you want, you can highlight over those and read more information about those different items. So let me actually take a minute here and talk about something called type code right here. And I'm going to scroll down here. And if you come from a C or C+ background, you would understand this C type comparison. Okay, so a signed integer is the minimum size in bytes. So you can go down and there's signed integers, unsigned, Unicode characters, in several different examples. So their equivalents in this type code are right here. So we've got the data type code that we're calling. So often when we talked about a data type, we've been saying an integer, a string, a Boolean. But this is our data type code. Okay, so F, and which I'm sure you've seen us use previously, we used the F when we were doing the sort of shorthand of concatenation. And if you were wondering what that was, now you'll understand. But okay, edit that out about F. Okay, and you can see here where F is a floating point with 4 bytes of memory, and D here is a floating point of 8 bytes of memory. Okay, so these are these type codes that we're referring to, and you're going to see they're going to come up. So if I go into array and I just type in array, and I go to here, and I put my quotation marks inside there. And what I want to do is I want to type in I. That's my type code. So when I go back to this, what I'm saying is do a signed integer of 2 bytes. Okay, and that's the first parameter in my array list. Okay, and in actuality, it is a parameter in the array, and you can see here that I've got my type code is the my initializer here. My string is sort of that code that it's looking for type code, and then it's my initializer. Okay, so let's take this here and actually move that up into there. And now I've got my array. And so why don't we go ahead and put that all into a variable. I want to assign that to numbers. Okay, and when I save that, obviously the formatting gets fixed. So now that I have this, I can actually manipulate all of the things inside my array. So I can say numbers, and I can do append, but I've got the whole list here, right? So I can just kind of scroll through all the different things that I want to do in here. So I can do, I can add a 5, I can add a 100, I can do whatever I want. Or if that's not what I really want, I can do instead an insert, and you can see it right there. Okay, so I can do those different things with this particular array. And just like lists, I've also got pop, and I've also got remove, and I've got reverse. I've got all sorts of methods that I can call now on that array of numbers. So I want to be really clear about one thing, okay, because we do have the ability to reference specifically one element or index, and we can do this and say that, let's say number 1. Okay, so when I talk about index 1, I'm talking about this. And notice here when I highlight over top of the 2, it tells me that that type is an integer. So the number 2 value there, the data type is an integer. So if I go to here and then I try to reassign it another value like a string, or let's say I don't want to do a string, I want to do a floating point number, I say this. Okay, and I run that. Let me save that and try to run that. And I'm going to get this error. Okay, so this integer argument expected. Okay, it's telling me I expected an integer because everything else in my array is an integer. Now it has to have, all arrays have to have the same exact data type. But what it said is, hey, my data types in my array were integers, but instead you're trying to give me a float. Okay, and that is not correct. So to make this correct, I would have to update that integer to this here. Okay, and so when I save that and then I run it, that is actually going to be permissible. Okay, now keep in mind, I don't have a print statement, so you don't see what the output is. I was just trying to show you what the error was going to be. Now let's go into here and look at this again and see what the options are. I've got a floating point. Okay, so if I go back up to here and I say change this to an F, and now if I look at all of these things and I save this, I look at this, it's still an int, but can I do this? Can I make that change? Let's see, does it show any problems if I run that? Okay. And am I getting any errors whatsoever? That's an old error. Let me clear that up and see if I can rerun that. And you notice I'm not getting any errors or any problems or anything like that. Okay, so let's switch that back to an integer, run that, and there you go. Sorry, I need to save it. I'll save it, run it. And you see that I'm getting this same error again. It says, hey, I expected an integer, but you sent me a float. Okay, so let's clean that up. Save and run it again, and everything is fine. I just don't have a print statement for it. And so like I said in the beginning, only use this when you're having performance problems or the size of your list is kind of growing out of control. Okay, so for the most part, you can stick with lists. They're really good, but until you get these problems with performance, then I would just stay away from the arrays for now. You're good to go with lists. Okay, I just want to thank you for sticking in with the video for this long. I know it's a lot of content yet again, but we're almost there. We're almost at the finish line. I would say we're somewhere around the 10-yard line if you're an American football fan. Anyway, the next thing I want to talk about really quickly is sets. Okay, so let's get over to Visual Studio and talk about sets. This is a really good example of when we have a list type of a data structure that has repetitive numbers, and maybe we want to get rid of those. So if I look at this and I say 1, 1, 1, 2, 2, 3, 4, 5, 7, 7, 7, maybe 8. We'll end off with 8. And I'm in my head, I'm thinking of something like weather data. Okay. And clearly with weather, you wouldn't be doing this as an integer, but for example, I'm going to do it as an integer. So if I want to say numbers and set that list to numbers, I can do that. But now I want to say, you know what, I want to get rid of all my repetitive numbers. So I can call this set on numbers. So sets is really kind of, in a way you can say it's more of a function call. And I'm going to set that to unique, Q-U-E-S. So uniques. Okay. And now I think what I'll do is I'll print that off. So if I want to print this and pass in uniques. Okay. And then let's have a look at this. Oops. Sorry. Let's have a look at this. Good. Now I'm going to run this and you can see what we're getting down at the bottom. Okay. I had a bunch of repetitive numbers here. I had 3 1s, 2 2s. I had 3 7s. And it got rid of all of that stuff. And I'm only printing out my unique numbers. Okay. So that's kind of a quick intro to set. And I want to highlight something to you that in the output of this, notice there was this curly brackets. Okay. On both the front and the back. Let's really quickly look at some of the things that we can do with this. So let's say I have another list, more numbers. Okay, and I take more numbers, and because this is a set, I want to put it in these types of brackets. I'm going to say 1, 4. No problem at all. Now, what I can do is I can say more more numbers, and I can call my add function. Okay, and then I can add, let's say, 12. That's one thing I can do. And let's say I do it again, more numbers, and I'm gonna say remove. Let's say I want to remove, say, 4. Okay, this is all stuff that I can do with my removing my 4. And now let's say one thing I want to do is I want to do my length. I want to know what the length of more is. Okay, more numbers is. Okay, so these are all the sort of typical things that we can do with a set. So I'm going to go ahead and save that. But let's see where this really starts to get interesting. Let me go ahead and clean up most of this. Okay, and I'm going to basically delete all of this stuff here. And I'm going to change this to 15, not 154. I'm going to just change it to 15. Okay, so all that stuff that I deleted is just pretty much sort of standard with some of the other activities that we've looked at before with lists and arrays. Okay, so now there's something that maybe I want to be able to do. I want to actually be able to make combinations. And I'm not necessarily talking about concatenation. Maybe it looks a little similar to that. But what I can do is I can do uniques, and I can call this thing, it's called a pipe, not this one here. Let's see if I can find it on my keyboard. It is typically your right beside your actual enter button, and it is shift, and it's sort of on one of your backslashes. So you got to look at it. It's typically right beside your enter button. Okay, and it's actually called the pipe. So I've got uniques and I've got more numbers. Okay, and let me go ahead and actually print that. That's why I put the brackets around it. So I'm going to print this out. So I'm going to go ahead and save this and rerun this. And now you can see what's happened. Okay, I've taken everything that is now unique and I've added it to this more numbers. And notice more numbers has a 1, but this also has a 1. Okay, but because it's kind of put it all together as a set, it's created this data set for me. It's only carrying one of the actual ones. So why don't I go and try and change this and find something here that is not in the list anywhere. Let's just go with 12. I'll change that to 12. I'm going to save it and then rerun this. And you can see now, if we compare it to the other one, just move that up a little bit. If we compare the two lines, you can see there's one extra digit here. It is the 12. Okay, it kept the 1, but it added the 12. Okay, so that's a really kind of cool thing we can do with sets. So let me go back and unchange that and make it 1 again. And the reason is I'm going to take this line of code, I'm going to copy it. And instead of this pipe, the what we sometimes call the or, and I'm going to change it to the and symbol or ampersand. And I'm going to save that. And now I'm going to run this. And you can see the difference here. What it's done is it's added the 1 from the first one, and it only created 1. But in my second set, it actually outputs the one unique number 1 there. So it's kind of showing the duplicate. So what it's saying is, hey, put out this one and put out this one, but put it into a nice, neat looking set of numbers. Now, what if I want to get the difference between the two? So if I copy that again, I paste it, and instead of this being an ampersand, I actually put a minus. Okay, so I'm going to save that one, clean it up, run that, and now look at this here. I'm getting the actual difference between the two. And the last one I'm going to do is the symmetric set. And that one is going to be the caret, the hi-hat, whatever you want to call it. I'm looking for it currently on my keyboard, but even me, I forget where it is because I don't use it very often. And it's just a shift and 6, the number 6. Okay, so I'm going to save that and run it. And now look at this output. Okay, so it's returning the items that are either in the first or the second set, but not both of them. Okay, now here is the most important thing to understand about sets. Okay, in that sets do not support indexing. So if I were to take, let's say, more numbers, okay, and then try to access it through one of its indexes or through an element, okay, this is not allowed. Okay, it is not going to happen. This is the one sort of limitation with a set. Okay, and if I do this, print, this is not going to allow this to go through. And you can see here, I'm getting this message and it says right here, value more numbers is undescribable object. Okay, it is a set. Okay, let's see, is there anywhere else I can get more info? Not really. That's the only place that I'm going to get this error. Okay, and the issue really comes down to it because it is a type of set. Okay, let's try this other one here. Instead of this here, let's see, will this make any difference whatsoever? And if I try to run that, do I get any difference whatsoever? Okay, interesting. I'm getting a difference here, right? It is actually allowing it to go through. Now, what about this one? What about uniques? Uniques. What is this one going to give me? Save that, and you can see already I'm getting a problem. Okay, and it's the same issue again. Okay, even if I run it, it says that the set object is not subscriptable. Okay, so it's a type error. So that's the important thing to really understand about sets. We're almost getting there, and the last thing I want to go ahead and talk about is going to be dictionaries. So let's do that now. Like I said, the last thing I really want to talk about now is dictionaries. And dictionaries really are a collection of something called a key value pair. Okay, and we've kind of alluded to this previously, but right now we're going to get into a little bit more detail, and then that's going to be it for this video because this is turning into a little bit of a marathon. Okay, a really good example of this might be, let's say somebody's home address is the key to the value, which is the person at that home address. So your home address identifies your place of residence. Okay. So let's look at an example again with coordinate. Okay, coordinates. We're gonna go ahead and bite the bullet and call it the full word. And I'm gonna create this key value pair relationship. And I'm gonna put it into these types of brackets. And I'm gonna say my first coordinate is going to be X, and it has a value of 1. Okay, and then I'm gonna do another key, which is going to be Y, and its value is going to be 2. Okay, so what you're seeing is I've got this key right here and a value, and my value in both of these happen to be integers. Okay, so it's really good to understand that when I highlight over this, I'm now dealing with a dictionary. Okay, and the reason I know that, other than highlighting over it, and it tells me that it's a dictionary, but it is this key and this value. Okay. Typically, though, we use either a string or a number because they're immutable, meaning they're, you can't change them. So we use strings or numbers here, but the values we can constantly update, or we have the ability to go in and do those updates. So just like we have our list function, we have our tuple function, We also have, of course, there's our set function. We also have the dict function, okay? And that's one of the ones in that list. So what's really interesting, because we've all, throughout the last, the long time that we've actually been running this video, we've talked about lists. We've called a list function. We've got a tuple, sets, and now finally dictionaries. So each one of these does have its own function. And when you highlight over this dict one, you can see that it's a class. And like I said, we're going to talk about that in the next video. But this is a class dict, and it does have this parameter list inside it. Now, what's really good is if I clean this up a little bit, there's a way that I can make this a little bit easier on my life. I can copy this again, and I'm gonna actually just copy this here and paste it, and then I'm going to use it to call this dict function. And the way I can do this now, a little bit more clean, is I can say x equals 1, comma, and y equals 2. Okay, so these two lines of code perform the exact same way. And, suppose I want to get the value of x, okay? And I'm going to say, where is it here? Coordinates. And I put in my brackets. In typically what you would initially be thinking is, okay, if I want to get the first one, I can put in 0 and I can get this to output. Well, in actuality, we need that key value pair relationship. We're not dealing with indexing or elements. What I have to do is say this is how I'm going to get the actual value associated or assigned to x. So now if I print this and I put this here, now I can actually get that value. So if I save that and do this, you can see now I get the 1. Okay, so if I tried to do this with a 0, save it, and then try to run that, now I'm going to get this error. Okay, and what it is saying is that this is a key error. All right, so let me go ahead and put that back. And this is how I access that value. I can't just call an index. I actually have to use the key and not the index to access that value. Now, everything after that starts to become very similar. Okay, so one thing I can do is, let me get rid of this. Okay, I'm gonna backspace that. And now I can change the value of x. So I can change that to 5. And if I want now to print this, so now I'm going to do print, and in here, I'm going to say coordinates. Okay, and now let's look at what the output is here. Okay, and you can see now that my new key value pair values is 5 and 2. So here's a really, really neat thing that I can do now. Let's say I want to add, so I don't have to deal with any of this business of, add or pop or anything like that. What I can do is just go here, and now I'm going to say, give me a new key value pair and add it. And I'll just change that to 25. So I'm going to save that, and then I'm going to print it out. And you can see now I've got X, Y, Z that are now part of my dictionary. Okay, so what happens now though, if what I want to do is access something that doesn't exist? So with coordinates, if I put this in here and I say, what is the value at, let's say, I don't know, A. We'll go to the other end of the alphabet. And I save that. Now look at this. If I go ahead and I run that, you're going to see right here that I get this same thing again, this key error. Okay, it's basically saying, hey, you've got a problem here because that does not exist. Now, suppose we want to delete one of the points. Okay, the one thing I can do, again, like we did before, is I can do delete. Okay, and I will say coordinates, and which one do I want to delete? So I'm going to do Z. Okay. And that's the one I want to delete from my list. Save this and run that. And you can see now I've actually deleted that third one, that Z one, from my dictionary. One thing I want to do is just really, really quickly show you how to iterate over a dictionary. Okay, and I'm going to do this for, let's say, X. No, I don't want to do X because I don't want to confuse you. I'm going to just say for I in coords. Okay, coordinates. Okay, and don't forget the colon at the end. We're going to say print and just print out the I. Okay, and let me save this. I'm going to comment out this right here as well. So there's only one print statement going to the screen. So I'll save that and let's see what happens here. Okay, and what you're seeing here is that I'm actually printing out the key, not the value. I'm printing out the key in this particular case. So if that's going to be the situation, if that is the intention that you want to do, then the best thing is to be very clear and say, I want to actually print out the key. Okay, and then in here, I'm going to write key as my first argument. And then I'm going to say coordinates. And within my coordinates, I got to move that out of the way. Within my coordinates, this is what I'm saying is go get me everything that is associated with that particular key. So save that. And now let's run this again. And you can see that I'm getting the key and the value. Okay. Now there is one more way that I can show you how to do this, to iterate. And I can go back and I'm going to change that back to I. Okay. And in coordinates, but in coordinates, what I'm going to do is I'm going to say dot. Okay. And see if it shows up. Items. Okay. It's not showing up. That's okay. But now what I can do is just go back to here and type in I. Okay. So save that. What it's saying is for I in coordinates items, and it's a method. Save it and let's do this and then run it. And you're seeing that I'm getting the same sort of thing, but I'm in a tuple format in this particular case. Okay, so that is kind of the difference between the two. In this way, I was not in a tuple, but now in this way, I am in a tuple. And then from there, if I want to, once it's in that, I can actually unpack this. So I can do something like this. Key, value, in points or coordinates items, and then print out just my key and value. Okay, and now that I've done that, I can do this, save it, and then run this. And you can see right here, very similar to the way we did it up above. Okay. Okay, I've had about as much as I can take making this video, and I'm sure for you, you must by now be starting to feel like Arnold Schwarzenegger going to the gym and cramming. Okay, so I'm going to end the video here, and just to really quickly recap, we've gone through lists, tuples, arrays, sets, and finally dictionaries. And that is one hell of a long video to throw at you guys. So again, I thank you for sticking by and watching this. And in the next video, I'm going to talk about classes and making objects in Python, because that is going to come in handy for us in the very near future as well. So thanks for watching, and I'll see you in the next video on classes.